I believe most of us are hungry now. So anyway, I will finish my presentation quickly. Uh, so this is being from the Chinese Academy of Science. So today I want to introduce the study about the basin scale surface water quality monitoring for the largest freshwater lake in China. Cannot work. So I will talk in 5 parts. So as you know, in China, the water is a big problem. The first one is the water has been seriously polluted in most of China. And the garbage and also the industrial pollution has been flowed to the river and lakes. Another one is the flooding. And in this year, July, last month, the many south of China, so many cities has been flooded. As you know, after the inundation area has been flooded, so the chemical and the pollutant will be transported through the flooding. This map shows the spatial distribution of the surface water quality in China, as we can see here. So here is the most developed area in China. So it's populated and also developed. But you can see the class 1 is the best water quality and it's the worst one. So we can see these parts, the water quality is very worst. And we see the China lake map here. The east part and west part. So this part, the most lake is nature lake. So the city is very few. But in this part is the mid and downstream of the Yangtze River. So these lakes has been polluted from more than 20 years ago. And we can see the Yangtze River Basin here. So here is the Shanghai and Nanjing. So this is Taihu Lake. So this area is the most rich basin in China. And also the lake Taihu has been seriously polluted. And here is the Poyang Lake is my topic because the Lake Taihu has been polluted. So the Chinese government has been put the many efforts on protecting the water quality in the Poyang Lake because it's the largest freshwater lake in China. So I will just take this one to protect the water quality. So Poyang Lake is the largest freshwater lake in China. The area is around 3,000 kilometers square, and the depth is around 25 meters. It's very deep, and the population is very huge. It's 45 million. So in Poyang Lake Basin, so we have 4 World Heritage sites and 3 National Historic sites and 2 UNESCO geoparks. So here we can just see the Poyang Lake here. So it's a Lushan mountain is around is very high mountain here. So we can just see the Poyang Lake here. It's very beautiful. About the water in Poyang Lake, actually, you can see the average and the highest and lowest water level is around 9 to 15 meters. So it's a very unique characteristics in China. So after the flood season and also the high flooding season, the lake area has been changed a lot. This shows the water quality and eutrophication condition in China. So we can see in Poyang Lake now the eutrophication level is also high. So that's why we have to put the effort to protect the water level or water quality in the Poyang Lake. So firstly, we have to get data for the water quality. So currently, we have the state key laboratory of lake and environment in our institute. And also, we have the Chinese Academy of Science key laboratory of watershed geography and the National Lake Watershed Database Center. We can share data from this center. And we have 3 floors Poyang Lake field monitoring stations here. So we just put data and monitoring in the Poyang Lake. So our purpose is to just conduct the water environment dynamic analysis, consider about the impact of the human activity and the nature factors. So we want to know, so among the agriculture sediment and also the water quality incident and the industry waste, how these factors affect the water quality in the Poyang Lake. As the slope skier, so we choose different land use to just to get the water quality for soil moisture and the water rainfall and the groundwater and also for the rivers. So we just put the monitoring equipment in different land use to get the slope skier water quality data. In the catchment scale, so we just use the remotion data and we just choose the forest, paddy field, and also the pond and the lake and also reservoirs to get the ground monitoring data to conduct the catchment basin scale model. And for the regional scale, we use the for lake part and for catchment part. So for each rivers, we have 5 rivers. Follow into the Lake Poyang. And we can just monitor the data in the river mouth of each rivers. So we can just get the emission data in the whole regional scale Poyang Lake. This shows the example of the data, the river discharge and also the water level in the different rivers. So we can just monitor the river water quality and also the water level for each rivers following to the Lake Poyang. So we can just use the river discharge and the water quality to calculate the nutrition node in the rivers and lake. So we can see here. So here actually is the biggest city in Poyang Lake. So the nitrogen and the phosphorus loading is the very highest in the Ganjiang River basins. And here is very many plants here. And also we have the sediment problem here. So it was the phosphorus situation is also good. And also for the groundwater sampling point, so we have our colleagues from China University of Geoscience. We also collect data for the whole surrounding the Poyang Lake to get the ground data for chemistry. But this shows the result about the water quality of the groundwater. So we can show just the groundwater quality actually has been highly impacted by the industrial and also the agriculture activities. So after we get data from the water quality monitoring, so how can we use the data? So we are now using the lake model and also the basin model to predict the water pollution in the lake and also the basin scale. So the main purpose is to generally use the model C equal to W2 model, and also we get the water quality, river discharge, and also climate data for whole basin, and to calculate the nitrogen, nitrate, ammonia, and also temperature for the whole basin and also the lake water. After this, so we will put the regional climate model, the GCM model result, and to see the extreme weather. Because from our monitor data, we can find in the season of the flooding and also the high temperature, the water quality somehow has been become more serious. So we want to see, so in the situation of the extreme weather, so how these factors has been affected on the water quality. So we use the spatial nitrogen phosphorus flow model to see, so for different scenarios, how the nitrogen and the phosphorus loading has been impacted for the lake and water and the basin scale, the river waters. So this shows the example of the distributed hydrogen model. We can see the river discharge can be simulated very well, but for the water quality, I think for the peak part and the low flow part, the result not so good. So we also conducted uncertainty analysis, but this model part actually we have some uncertain problem about the water quality collection. So the modern part is just started. And for the lake part, and it just shows the example of the model output. We just use the export from the basin scale, the nitrogen and the phosphorus and COD loading. We can just simulate the spatial and temporal distribution of the COD, DO, and T, the total nitrogen, like that. And also for the inundation, because here is Yang River, so now we have put another project on the river mouth. So we want to see after the project has been launched, so how the lake water level has been affected by the Yangtze River. So we also simulated the inundation in the Poyang Lake. So the challenge and the problem, actually this problem also is almost similar with most of research here. And the first is the information gaps, because in the Poyang Lake Basin we have many department and institutions. So recently we have launched one office. The office is the Mountain River Lake. Mountain is the lake, Poyang Lake Basin. River is the 5 rivers to the Poyang Lake. Lake is the Poyang Lake. So we launched one new office about the Mountain River Lake Development Committee. So this committee will communicate in university, Chinese Computer Science, and also hydraulic department and the environment department. So we can share data and information and also report the policy from the government. So we just to reduce the information gap through our effort. Another is the problem is the parameters, because the monitoring is very huge. So we need a lot of the funding to install the instrument. So for groundwater and for the surface water, real water, lake water, we so far, so most 7 parameters have been monitored. So depending on project, we will just choose some important site to get more information about the water chemistry. And this also has been mentioned by of researcher last day. So as we know, we can see this is the river network. So here is the runoff station. This is the water chemistry station, water quality station. So in most of places, the water quality station and the water quantity station, they are not the same place. So they are not so combined in the different department. So we have to, the committee have to communicate to get data and to build more. Because in China, this kind of river network not so easy to build the river network, because the station has been controlled and managed by different departments. And for the effective communication with society, so we already put many effort to get more public participation through different departments and also for the local people. So we can just report our results and also the data on the internet. So the official will just control data and also give us the feedback to the report, also the feedback, the data monitoring and the model result. And another problem is most the data and also the website is only available in Chinese, so not so international. So this also is a shortcomings. So we have many monitoring sites, but still very local part. And for the rural area, we also need some more the monitoring stations. Yeah. So sorry, the time is so I've just show the so from monitor model how to get the result to the society. So we just so it's before now. So from data to forest, we have put many effort to change the nature, and we can also build many water treatment system. And finally, I want to show 5 pictures to show good example to protect the environment in rural area. Actually, I rated this year the Miyama village in Japan, in Kyoto prefecture from here around 1 hour. So I think it's a very good example to protect the rural area. So we can see the water, air, and also the environment is very good. So I think the Miyama is a very example to discover the rural Japan. So if you have time, please go there to study some things. Okay, thank you.
Thank you very much. I have a question. I have a question. Thank you for your very interesting presentation. What kind of satellite data do you use?
We use different. One is the QuickBird, one is the MODIS, and also because we have the data center, so we have the most specialists in our institute. So we use 5 or 6 products. Yeah.
The distributed lake model is 1 layer or 3 dimensional model?
3 layers.
3 layer?
Yeah.
Oh, I see. It's interesting to combine.
Yeah.
If you have any question for him quickly, or please do it very quickly.
Okay, Professor, thank you very much for your nice presentation. Actually, I'm from Jiangxi province, so I'm very familiar with here. So I want to know, so now Poyang Lake, it is eutrophied or not? And according to what I know, Jiangxi government will develop a big industrial zone in around the Poyang Lake. So what is the possible impact of the development of this industrial area? So in the future, I mean, the pollution in Poyang Lake will become more serious or not? Thank you very much.
Yeah, I think we will become more serious, actually. So now, you can see here, now we have another project about the transfer the industry from Shanghai, Nanjing to inland area. So because here already well developed area. So in Jiangxi province and Wuhan area, so this area is somehow poor. So we have to transfer, because Jiangxi province, they hope to import the industry to the province. So we are now focused on how to reduce the.
So I would like to close this session because of the time is limited. So thank you very much, presented.
Okay, thank you.